This is the video lesson for how to determine acceleration from a velocity time graph. The learning target for this lesson is, I am learning to determine the acceleration of an object using a velocity time graph. The success criteria for this lesson are, I can understand that an object's instantaneous acceleration is equal to the slope of a line tangent to a point on the velocity time graph. And I can determine the average acceleration of an object by calculating the slope on a velocity time graph. All right, so now we're looking at a velocity versus time graph. All right, so this is velocity on the y-axis and time on the x-axis. And here we have an object that is speeding up over time. So we can figure out the instantaneous acceleration of this object by taking the slope at any point. So if we wanted to know the instantaneous acceleration of this object at 11 seconds, we would figure out the slope of the line tangent at this point. So whatever the slope is of this line at this point, we could calculate that, and that would give us the instantaneous acceleration of this object at that moment. If we wanted to figure out the average acceleration, similarly to with a position time graph, we would just pick 2 points on the graph and figure out the slope. So if we wanted to know the average acceleration of this object from, let's say, 5 seconds to 13 seconds, we could draw a line here. It's a bad line. So figure out the slope of this line, and that would give us the average acceleration from a velocity time graph. Okay, so again, we have a velocity time graph. So velocity is in meters per second, time is in seconds. So here we have constant acceleration. So constant acceleration because we have a constant slope. So the slope of a velocity time graph gives us the acceleration. So if we have a constant slope, that means we have constant acceleration. So we have constant acceleration here and constant acceleration here. Now these points right here, we have no acceleration. The slope of the line here is 0, and here, no acceleration, because the slope is 0. So the object is moving at, right here it's moving at 4 meters per second, and here it's moving at a -3 meters per second. So it's not changing its speed at these points where there's 0 slope. Here, if we wanted to figure out the average acceleration over this period of time, which is 7 seconds, so we have 7 and 4. We can say here we have 0, 0. So if we want to figure out the average acceleration, which along this line is also the instantaneous acceleration at any point on this portion of the graph, we have again our slope equation is y2 minus y1 over x2 minus x1. So we have our acceleration is equal to, and we could call this the average acceleration, is equal to 4 minus, so it would be 0, nope, sorry, this is positive, 4 minus 0 over 3 minus 0. So it would be 4/3. This would be meters per second, and it's per second. So our units for acceleration are meters per second squared. So we have 1 1/3 meters per second squared. And you can easily put this in decimal form. So it'd be 1.33 meters per second squared. I'm just putting in fractions because it's easier for me to calculate that way. Now this section here, the object is slowing down until it reaches 0, at which point, so here it's moving in a positive direction, but it's slowing down. So from here to here, it's moving in a positive direction, but it's slowing down. And then when it reaches the 0 point, it's turning around, and now it's going in a negative direction, and it's speeding back up again. So, but the acceleration is negative the entire way. So if we figure out the slope of this part of the line, we can figure out what the acceleration is. So here our address is, in the x-axis it's 10, and our y-axis is 4. And here our x-axis is 14, and our y-axis is -3. Okay, so we do, to figure out our acceleration, and this is average acceleration again, it's -3 minus 4, because it's y2 minus y1, and then x2, that's 14 minus 10. So we have -7 over 4. So our acceleration is -7/4, which would be negative 1 3/4. So that's 1.75. So negative 1.75, and that's meters per second squared. So that's the acceleration at this point. So it's slowing down at this point. So it's slowing down from here to here. The object is slowing down from here to here in a positive direction, and then it turns around at the origin, and here from this point to this point it's speeding up in a negative direction. Okay, so what have we learned in this lesson? We've learned about instantaneous acceleration, which is the slope of a tangent line to a curve on a velocity time graph. And we learned about average acceleration, which is the slope on a velocity time graph. All right, everybody. Thanks a lot.